Welcome to IIT Chemistry. So dear viewers, in this video we are going to discuss MCQ on amino acids and peptides for IIT JAM, NET and GATE as well. So in this video only we will discuss the questions one. During the solving of question, we will discuss how to solve this question, and also in some extent we will discuss about the theory part, and I will give you some tricks so that in future you are going, when you are solving the questions regarding amino acids and proteins or peptides, you will not feel any difficulties. So without wasting our time, let's start our today's video on amino acids. Question number 1. Amino acid is the monomer of which biomolecule? The options are carbohydrate, protein, nucleic acid, lipids. Dear viewers, try to answer this question. So, if we will answer this question, the option number B is the right answer. Why? If we will analyze all the four options, carbohydrate is nothing but polymer of monosaccharides. If you look at this structure, you will see this is the sucrose, this is the monomer of glucose, polymer of glucose, fructose, lactose, this is the combination of galactose and glucose. Then if you go to the another option, like second option, protein. Protein is nothing but combination of amino acid and amino acid combine with each other to form peptides or proteins. And you can say amino acid is the building block of proteins. If you go to the nucleic acid is nothing but polymer of nucleotides, and nucleotides is nothing but a combination of pentose sugar, nitrogen base and phosphoric acid. Okay, so if you go to the option number D, lipids. Lipid is nothing but glycerols. Monomers are the glycerols. Glycerols combine with each other form the lipids. So option B is the correct answer for question number 1. Then we will move to our second question. Which one is the correct matching? A and B. In A we have carbohydrate, protein, nucleic acid, lipid, and in B, section B, we have amino acid, glycerol, monosaccharide and nucleus. If you will match A with B, here if we look at the question, A is nothing but polymers, B is nothing but monomers. A are all the biomolecules. If we will match carbohydrate, the monomers is monosaccharides. Protein, the monomer is nothing but amino acid. Nucleic acid, the monomer is nucleotides. Lipid, the monomer is glycerol. So this is the right combination for this matching. So this is the actual answer of this question. Okay, so if we go to the next question, what is the next question? Amino acid contains which functional groups? So option number A is carboxylic, B amine, C both amine and carboxylic acid, D is none. This is very basic question of amino acid. If we look at the structure of amino acid, one carbon is this carbon is attached with carboxylic group, amine group and hydrogen. These three groups are compulsory for an amino acid, and this group The fourth position, fourth group is R that can be sensed for different amino acid. That can be hydrogen, can be methyl, can be benzyl, whatever group. So depending upon the substituent R, the name of amino acid will change. So for this question, which one is the correct answer? Amino acid contain which functional group? Basic structure of amino acid. If we will consider the basic structure of amino acid, so C is the correct answer. Okay. So moving to the question number 4. How many amino acids take part in protein synthesis? So this is very fundamental question. You know, in protein synthesis, amino acids are the building blocks. Amino acids combine with each other to form protein. So among these are the four options: 22, 20, 21, 10. So you will often confuse that the option number B or option number A. So if I will answer this question, the option number A is the correct answer, because 22 amino acids take part in protein synthesis. So if you go to the question number 5, again another the same question: how many amino acids known as proteogenic or natural amines? As these 22 amino acids take part in protein synthesis, that's why again these 22 amino acids are known as proteogenic amino acid or natural amino acid. The option number A is the correct answer. Then another interesting question: how many amino acids are encoded by universal genetic code? So if you answer this question, then that only among 22 amino acids, 2 amino acid is completely different, as these 2 amino acids incorporate into protein synthesis by unique synthetic mechanism. What are these 2 amino acids? These 2 amino acids are selenosystine and pyrrolysine. So question number 6 answer is 20 is the correct answer, because this only out of 22 amino acid, only 20 amino acid directly take part in protein synthesis and encoded by universal genetic code, except 2 amino acid. So option number B is the right answer. Okay. So dear viewers, you have to remember the name of all the 20 amino acids. So to remember the all total 20 amino acids, I will give you a trick how to remember all these 22 amino acid alphabetically. If we will go alphabetically, first alphabet A comes. So A, in A alphabet we have 4 amino acid, that is alanine, arginine, aspartic acid, asparagine. Okay, in alphabet A we have 4 amino acid. If you go to alphabet B, B has no amino acid. If you go to C, C has only 1 amino acid, that is cytosine. C, then D, D has no amino acid. Then E has no amino acid. Then F, F has no amino acid. Then G, G has G, we have in G 3 amino acid: glycine, glutamic acid, glutamine. Then H, H has only 1 amino acid, that is, what is that amino acid? Histidine. Then GH, I, isoleucine. IJ, J has no, IJK, L, 2-lamellocene, leucine and lysine. Okay, Gale M has only one amino acid, methionine. N has no, KLMN, O, P has phenylalanine and proline. Q has no R, no S, serine. PQRST, tyrosine, tryptophan, threonine. Then U has no V, valine. Okay, these are 20 amino acid alphabetically you have to remember. In A we have alanine, arginine, aspartic acid and asparagine, 4 amino acid. In C only one amino acid, cysteine is present. In G we have 3 amino acid, glutamine, glycine, glutamic acid, glutamine. In H we have histidine. In I we have isoleucine. In L we have leucine and lysine. M methionine. P phenylalanine and proline. S serine. And T tyrosine, tryptophan, threonine. So other than this 20 amino acid, we have another 2 amino acid which take part in protein synthesis by unique synthetic mechanism. So these 2 amino acids are selenocysteine and pyrrolysine. Okay, these 2 amino acids. So if we look at the structure of these amino acids, you have to remember the structure of these 22 amino acids, because in the MCQ question you will be asked about the structure of these amino acids. So I will give you a trick to remember this 22 amino acids, structure of this 22 amino acids. First we will go to this structure. You listen, this thing, this is the this NS2 carboxylic groups and hydrogen. These are fixed. Only change is here. Okay. If you change this position as hydrogen, the name of the amino acid is glycine. If you change this position CS3 as CS3, the amino acid will be alanine. If this one will change, listen, if here only benzyl group will attach, then the name of this amino acid will be phenylalanine. If this benzyl, if only in this position one OH will attach, listen, OH will attach this position, the name of the amino acid will be tyrosine. Similarly, if here only CS2 is there, if CS2 directly attached to OH, then this will be serine. If this CS2 will attach to SS, thiol group, mercaptan group, the name of the amino acid will be cysteine. If this CS2, listen, only CS2 connection, I am telling you only CS2 connection here. If this CS2 is connected to this indole group, okay, this is nothing but indole group, the amino acid is tryptophan. Okay, if this CS2 is directly attached to this imidazole ring, this is nothing but imidazole ring. Okay, so imidazole ring, and this name of the amino acid is nothing but histidine. This is only CS2 connection. I am talking only CS2 connection. This position CS2, and this CS2 will directly attach to this carboxylic group. Name of the amino acid is nothing but aspartic acid. If this CS2 will attach to CONS2, an amide group, okay, the compound is nothing but asparagine. Listen, aspartic acid and asparagine, what is the difference? This is carboxylic group and this is acid amide group. Okay, amide group. Only the derivatives of this carboxylic group. Aspartic acid, asparagine. If we go to the another structure, listen, This is a CH2 connection. The CH2, the hydrogen will two hydrogen C. This one will attach to a isopropyl group. Then this name of this amino acid is valine. If this CH is attached to one CH3 and one OH, and the name of this compound is threonine. Listen, all are CH2 derivative. Here CH2H will be alaline and two hydrogen will replace by CH3 group. This is valine. If a two hydrogen will replace by one OH, another is CH3, then this will be threonine. Okay. So all are CH2 substituent. Then we will move to another CH2. Only one CH2 is there. Only one CH2. Another CH2 will come, that will attach to carboxylic group. And name of this amino acid is nothing but glutamic acid. What will the glutamine? Like asparagine, here amide group will attach. Okay, this will be go to the glutamine, and name of the amino acid is nothing but glutamine. Okay, all are CH2 substituent. Two CH2 group are there. Here carboxylic group, that is glutamic acid. Here is amide, that is a glutamine. Okay, if CH2 and CH2 is there, here ACS3 sulfur will linked with CH3, then the compound name is only M in the M alphabet, methionine. Compound amino acid name is methionine. If you will go to this CH2, listen, CH2CH is HHO2 will replace by 2 CH3 like valine. Okay, valine one direct will attach, and here this isopropyl group will attach. Name of the amino acid is nothing but leucine. Okay, if this in place of this isopropyl will move to this carbon. Okay, second carbon, then CH3 CH2 CH3. So this CH3 will come to this position. This is nothing but isoleucine. Okay, so we'll move to the next amino acid. So here to one CH2, second one CH2, then second CH2, then third CH2, four CH2 group are there, that will directly attach to NH2 group, and name of the amino acid lysine. Lysine is the special case of amino acid where 4 CH2 group is attached, and that will attach with the NH2. So lysine. Okay. Then arginine is the different case of amino acid. Listen, CH2, 3 CH2 are there. Then this CH2 is attached to this NHCO guanide group. This is guanide group. Guanide group is attached. Okay, guanide group NH2. Okay, so that's why this amino acid is more basic in structure. If we go to the most interesting amino acid, this is the proline. So here this is carbon NH2COH. Here secondary amine is attached. So proline is the only amino acid which contains secondary amine group. So proline, this carbon is attached to, this is the main carbon which is at a carboxylic group amine, and this is cyclase. So this is the only cyclic amino acid and having secondary amine group. So this is the proline. So these are, if you look at this structure again, you will see. So first glycine, hydrogen will replace, then this is glycine, then CH3. If CH3 they are alaline, and CH3 2 hydrogen will replace by CH3 valine. If that will replace by benzene ring, that will be phenylalanine. Again that benzene will attach to OH group, that will be tyrosine. If CH2 OH is there, that is serine. If CH2SS is there, that is cysteine. If CH2 is directly attached to the indole group, that is tryptophan. If CH2 is attached to the imidazole ring, that is known as histidine. Again CH2 is attached to COOH group, that is aspartic acid. If amide group attached, this is aspargine. If CH2, CH3 alaline, two hydrogen replaced by CH3 group, isopropyl group are there, that is valine. If one CH3 is replaced by OH group, then that will be threonine. So this is the difference between valine and threonine. Here one OH is there, here CH3 is there. Okay, CH3 is there. So this is the difference between threonine, valine. So CH2, CH2, CO, so two CH2 group is there, that is glutamic acid, and CH2, CH2 amide is glutamide. Methionine, CH2, CH2, CH3 is present, that is methionine. Leucine, isoleucine, CH2, CH2, two CH2 is there, but second CH2 is replaced by isopropyl group, and here first group is replaced by CH3. So this is the difference between leucine, isoleucine. Okay, if we move to the leucine has 4 CH2 group. Okay, what is 4 CH2 group is there. Okay, in case of arginine, 3 CH2 is there, but again that CH2 attached to it is one hydrogen group. Okay, proline, this is nothing but special amino acid, that is cyclic amino acid. Okay, so moving to the another two different amino acid, structure of two different amino acid, that is selenocysteine and pyrrolysine. Selenocysteine is similar to cysteine. Okay, in cysteine we have SH group instead of S group. Here in selenocysteine selenium is present, that's why name of this amino acid is selenocysteine. Okay, if you go to the structure of pyrrolysine, okay, it is also similar to lysine structure. So in the last slide already we have discussed the structure of lysine. In lysine we have 1, 2, 3 and 4 CH2 group are there. Here NH2 will be there, so that will be lysine. But in case of pyrrolysine, one hydrogen is replaced by this CO amide substitution, and this is pyroline. So this is substituted by pyroline group. Okay, pyroline group. So lysine and pyrrolysine similar structure, only difference is there in NH2. Here NH2 one hydrogen is replaced by pyroline carboxypyroline group. So this is the structure of what is pyrrolysine and selenocysteine. So now you will tell me what is the use to remember the structure of this 22 amino acid. Now I will tell you why we remember this structure. If we go to the next question, the question is asked which amino acid contains imidazole. So you have to remember the structure of all the amino acids so that you can know which amino acid contain which group. So what is the answer of this question? So imidazole contain which amino acid? Histidine. Histidine is the answer. Okay. So moving to the next question, which amino acid contain indole ring? So indole ring contain which amino acid? Try to answer. Tryptophan. Tryptophan contain indole group. Okay. Next, moving to the next question, which amino acid contain phenolic group? Phenolic group CH2, benzene ring, then OH is there, that is serine. Serine is the answer. Okay. So if we move to another question, so these are the answer of this questions. Okay. So if we will move to the next question, which amino acid contain amino group present in secondary amino acid? Which amino acid? The amino group present in secondary. That is very simple. That is proline is the only amino acid which contains secondary amino. Okay. If we move to the next question, which amino acid contain thiol or mercaptan group? Thiol SS group. SS that is cysteine. Okay, cysteine. OS that will be serine. If SS is there, CS2SS, then this is no doubt cysteine. Okay. If we move to the, so this is amino acid which contain 12 question isopropyl group. Isopropyl group, that is nothing but valine is the answer. Okay. So valine amino acid contain isopropyl group. What is isopropyl group? Now we are moving to the physical properties of amino acid. Here question number 30. Which statement is false? A. Amino acids are generally colorless, crystalline solids. Amino acids are soluble in water due to Jupiter ionic form. Amino acids are low melting solids. All amino acid is amphoteric in nature. To solve this question, we have to discuss the structure of lysine amino acid. So this is COOH group and this is NH2 group. Okay, and this here one hydrogen will be there, here one R will be there. Listen, amino acid contain both carboxyl group as well as NH2. So this carboxyl group has a tendency to donate one proton or hydrogen. This amine group has a tendency to accept one hydrogen. That's why the amino acid remain in this form CO minus and NH3 plus, and this form of amino acid is known as Jupiter ion. What is Jupiter ion? Jupiter ion. So amino acid, all the amino acids remain in Jupiter ionic form. So this is both the cation as well as anion present. That's why the name of this form of amino acid is known as Jupiter. As this is remain in ionic form, Jupiter ionic form, anionic bonds are present, both anions are present. So amino acid, all the amino acid is ionic compounds, and as these amino acids are ionic compounds, so these are crystalline solids soluble in water, and as both acid and base is there, so generally amino acids are amphoteric in nature. So if we look at the option, amino acid, option number A, amino acid are generally colorless crystalline solid. Yes, this is a correct statement. Then we will move to the option number B. Amino acids are soluble in water due to Jupiter ion. Yes, correct answer. Amino acids are low melting solids. This is false, and this is the right answer. Amino acids are crystalline solids. The melting point should be high. And the question number D, all amino acids are amphoteric in nature. Okay, so which one is the false statement? Amino acids are low melting solids. So we'll move to the question number 13. Isoelectric point. Okay, isoelectric. What is isoelectric point? Isoelectric point is nothing but, okay, is nothing but the pH at which amino acid remain in Jupiter ionic form. What is Jupiter ionic form? So the isoelectric point of amino acid is the temperature at which amino acid melts. This is wrong. The pH at which amino acid remain in cationic form, that is false. The pH at which amino acid remain in deuterionic form. Yes, this is the right answer. So C is the right answer. Okay. We will move to the next question. Which one is the correct behavior of amino acid when placed in electric field? When amino acid is placed in electric field, amino acid, okay, at low pH, amino acid remain in cationic form, migrate towards the cathode. At high pH, amino acid remain in anionic form, migrates towards anode. At an intermediate pH, amino acid remain in electrically neutral form. All of these. Which one is the correct behavior? So at intermediate pH mean isoelectric point, amino acid remain in neutral form. That is correct. So if we draw the structure of amino acid here, CCOH and NS3, NS2. Okay, here R and here H is there. So suppose I will write here COH and NS2 is there, and here are hydrogen. So first at low pH means acidic condition. So in acidic condition, if H plus will be there, acidic condition, and here at high pH mean basic condition, OH minus will be there. So H plus this NS2 will be protonated to NS3 plus. Okay, so NS3 plus, that means cationic form. At a low pH, amino acid remain in cationic form, so cation will migrate to cathode. That is correct. In at low pH mean basic condition, COH convert to CO minus, that is anionic form, that will migrate to anion will migrate to anode, that is correct. At intermediate means deuterionic form, that is both positive negative, electrically neutral form. Deuterion means that will remain in electrically neutral form, CO minus, okay, minus R. So here that will not migrate to any electron. Okay, so answer is all of the above is correct. All the statements are correct. To explain the last question, so I am going to give you some theory regarding isoelectric point. So isoelectric point is nothing but pH. Isoelectric point, Pi, is nothing but pH. The pH at which the amino acid remain in deuterionic form. Listen, this is the deuterionic form of amino acid. In deuterionic form, some pK value will be given for this carboxyl ion, and pKa will be given for NH3. So pK and pKb are complementary with each other. pK plus pKb is equal to 14. So you can give pK value of amine and pK value of carboxylic acid here. So what is isoelectric point? Amino acid are hydrophilic colloids. Depending upon the pH of the medium, they move either towards the anode or towards the cathode when placed in electric field. Okay. In acidic solution, that is at low pH, the deuterion takes up a proton from the acid and exists as cationic form. So it migrates towards the cathode. That things already I have told you. In alkaline solution, that is at high pH, The deuter ion donates a proton to the alkali and exists as anionic form. So it migrates towards the anode. Amino acid bears a positive charge in acidic solution low pH and a negative charge in basic solution, that is at high pH. There must be an intermediate pH where the amino acid is evenly balanced, positive charge and negative charge balanced, electrically balanced form between two forms as the dipolar deuter ion form with a net charge 0. This pH is called as isoelectric pH and the isoelectric point. So isoelectric point is nothing but pH at which the amino acid remain in deuter ionic form. So this is deuter ionic form. So if we will increase the S plus concentration, that is at low pH, okay, it will remain in this form. Okay, this one will amino acid will remain, suppose this is amino acid COOH. Okay, what I have told you in theory. Next2 here R and here one H is there. Okay, at low S plus, at low pH means one S plus will abstract by this lone pair of amine to form this. At low pH, the amino acid remain in this form. Okay, so this is the overall charge is positive cationic, so that will move to cathode. Okay, that is cationic. So cathode is the electrode where the cations are attracted, cations to cathode. Okay, again at low high pH. High pH means more less OH concentration, more OH minus, sorry, OH minus concentration. So that OH will abstract one proton here, that will remain in this form. Okay, at high pH the amino acid remain in anionic form and that ion will migrate towards the anode, that is towards anode. And here this amino acid is attracted towards cathode. Okay, so this is the theory behind our last question. Okay, then we'll move to the question of isoelectric. How will calculate the isoelectric point? Listen, so this is the amino acid glycine. So to calculate the amino acid, you will be given pK, a value of this OH acidic group and a pK value of amine group. If 2 pK value will be given, so we have 3 type of question generally asked regarding isoelectric point. Suppose this is a neutral amino acid. Neutral amino acid means one carboxylic group, one NH2 will be there. So 2 pK value will be given. Then to calculate isoelectric point, this is very easier. Okay, Pi is equal to half pKa plus pKa1 plus pK2. So this 2.3 by plus 9.78 divided by 2. So you'll get how much? 2.3. That is the answer. Okay. So if you calculate the isoelectric point of proline, so this is 10.60 and this is 2. So 10.060 plus 2.00. So total will be 12.60 divided by 2. So Pi will be 6.30. So 6.3 is the isoelectric point of proline. Okay. So if we move to the next question, calculate the isoelectric point of aspartic acid. So from the given pK value, listen, in case of aspartic acid, one carbon, this is a acidic amino acid, as one extra carboxylic group is there. Listen, these two are extra carboxylic acid. Okay, so due to this extra carboxylic acid, we have one pK value for this one pK value for this one pK value for this one. So in this case, how will calculate the pK value? Listen, pK, how will calculate the isoelectric point? Here we have 3 pK value. Isoelectric point is nothing but pH at which amino acid remain in isoelectric. So for acidic, the pH will be less than 7. So in this case, if 2 acidic group there, the smaller group will divide by 2. That means 1.95 plus 3.71 divided by 2. So that will be the answer. So you will calculate, the option will be given, you will calculate. So approximately 2 point something will 3 point something will come. Okay, 2 point something or 3 point something will come. Okay, whatever will come, I am not calculating for that. So another type of calculate the isoelectric point of glutamic acid. In glutamic acid, same case, we have one 2.16, another 9.58, another 4.15. So smaller will, as this is acidic proton, so smaller will be 2.16 plus 4.15, 2 smaller divided by 2. So answer will be 6.23. So 3 point something. Pi will come 3 point something. Okay. If we'll move to the next question, calculate the isoelectric point of 16. In case of 16, same. So 16, this is amphoteric in nature. If you consider as a acidic amino acid, so here 2.05, 8.0 and 10.0. So which two are small? These two are small. So we'll divide these two, 10.05. So Pi approximately will come 5 point something. Okay. Similarly, if we'll calculate the isoelectric point of tyrosine from the given pK value. So tyrosine, this is the structure of tyrosine. We have one pK value, this is one pK value, and this is another one. So this is, if you consider this is acidic amino acid, as a phenol is acidic in nature, so smaller will be taken into account. So this is 9.11 and 2.00. Okay, 9.11 plus 2.20 divided by 2. That will be Pi. Okay. So what will be the answer? That you have to calculate. So if we'll move to the another type of amino acid. Listen, in this case we have two NH2 group. In case of lysine, listen, we have a pK value 8.95. Here pK value is 10.53 and here 2.18. So this is basic amino acid. So it has a more pK value 8.95. For amine, pK value 10 point. So in this case, larger pK value will be taken into account. So 8.95 plus 10.53. Okay, what will be the answer? That will be divided by 2. So that will be the Pi value of isoelectric point of lysine. So if we go to the another type of question, histidine. So histidine, in case of histidine, we have this imidazole ring. So this PK, NH-PK will be given you. So this PK will be given you, and this PK will be given you this. So as this is basic in nature, so larger will divide. So this 2 will be taken into account. 9.18 plus 6.10. Okay, so divided by 2. That will be the answer. This answer will be calculated. So basically for acidic amino acid, the smaller pK value will be taken into account and divided by 2. And in case of basic amino acid, means extra NH2 will be there, then larger pK value will be taken into account, and that will sum and will be divided, the sum will be divided by 2. So that will be the Pi value of the compound. So the last question regarding isoelectric point is arginine. In case of arginine, same thing, this is a basic amino acid. So we have a 1 NH2 group, 9.05, here 1 pK will become, this NH2 will not given, so that will be given to you. pK value will be given to which pK value, which atom pK value will be given to you, pK value. Here is another pK value. So we have 2 larger pK value, and that will divided by 2, 9.04, 12.48 divided, it will sum, and that will divided by 2. So we'll get a Pi value. Okay. So in this way, we'll calculate the isoelectric point of any amino acid if pK value will be given. So if we'll summarize the Pi value isoelectric point, how to calculate the isoelectric point of a given amino acid if pK will be given, then for negative charge amino acid, negative charge means that is CO minus. Okay, negative charge means CO minus will be extra. Okay, negative and positive, one positive will cancel out. If extra CO minus will be there, then this will be negative charge amino acid. So larger pK will be the sum of 2 small pK value divided by 2. For a positive charge amino acid means basic amino acid, so CS3 plus, another will be CS3 plus, and this will cancel with CO minus. One extra positive charge will be there for basic amino acid. So in this case, sum of 2 larger pK value divided by will be 2. We'll get isoelectric point of given amino acid. So in this way, we can calculate the isoelectric point of a given amino acid. Very easy. So already in the exam, it will be given the pK value. So you have to only identify this is a simple amino acid. If simple amino acid is there, then 2 pK value sum divided by 2. If this is acidic amino acid, 2 small value will be given, 2 small pK value divided by 2. If this is a basic amino acid, means positive charge, net positive charge will be there in amino acid, that is basic amino acid. Sum of 2 larger pK value divided by 2 will be given you the isoelectric point of that amino acid. Okay, now we are moving to another section of amino acid, classification of amino acid. So this question indicates which amino acid is not an essential amino. As you know, on the basis of nutritional point of view, amino acid divided into two types. One is essential, another is non-essential. Essential amino acid, the amino acid which is not synthesized our body, we have to take in our diet. Non-essential amino acids are already in our body, so we don't need in our diet. So also amino acid divided into different classified on the basis of polarity, polar amino acid, non-polar, or a negative charge amino acid, positive charge, and there are so many classifications. Here, which amino acid is not an essential amino acid? So how will know? Valine, lysine, alanine. So there is a formula. There are two types of amino, essential and non-essential. So among the 10 amino acids are essential. Among 20 amino acids, essential. So remaining 10 non-essential. Non-essential. So what are the 10 amino acids which are essential? There is a formula or there is a trick to remember the 10 essential amino acids. That formula is VIP whole में 50. So V stands for valine, I stand for isoleucine, P stand for phenylalanine, S stand for histidine, A stand for arginine, leucine, lysine, methionine, threonine, and tyrosine. Okay. So here, which amino acid is not essential? Listen, valine is essential, lysine is essential, tryptophan is not an essential. So answer is tryptophan. Okay. So another, which amino acid is hydrophilic or polar amino acid? To know the hydrophilic and polar amino acid, we have to remember the structure of amino acid. Hydrophilic means polar group should be there in amino acid. So here question, amino acid is hydrophilic, polar amino. Which amino acid? Hydrophilic means histidine, phenylalanine, polar group, CS2PS is there, benzoline, valine, isopropyl group, isoleucine. Isoleucine also isopropyl CS2, CSC isopropyl. So histidine having a imidazole ring, so histidine NH2 polar group are there, so histidine is the answer. So you have to remember the structure to counter this type of question. Which one is a negative charge amino? Negative charge means always deuterium having positive charge, negative charge, that will cancel with each other. If extra amine will be there, that will be positive, extra net positive charge will be there. If the amino acid contain extra carboxylic group, so net negative charge will be there. So negative charge amino acid means extra carboxylic group will be there. Histidine, aspartic, lysine, arginine, histidine. Obviously aspartic acid because CS2COS is there. So this is the answer of these three questions. So this is on the basis of structural determination. So now we'll know which amino acid. To remember the essential amino acid, I have a trick for you. So essential amino acids are valine, isoleucine, phenylalanine, histidine, arginine, leucine, lysine, methionine, tryptophan, threonine. So these 10 amino acids are essential amino acids. So that can be remembered by using a formula VIP Holme TT. V stands for valine, I stands for isoleucine, P stands for phenylalanine, S stands for histidine, A stands for arginine, L stands for leucine, L lysine, Me stands for methionine, TT tryptophan threonine. Listen, in T tryptophan threonine are essential, but tyrosine is not essential. Okay. So methionine, M, lysine, leucine is there. Okay, arginine, there are 4 amino acid containing A is there, but arginine is essential amino acid. So you have to remember accordingly. So these are non-essential amino acid. Another 10 are non-essential: alanine, aspartic acid, asparagine, cysteine, glycine, glutamic acid, glutamine, proline, serine, tyrosine. So these are essential 10 amino acids, these are non-essential amino acids. So there are 2 amino acids which are semi-essential. These 2 amino acids are histidine, arginine. These are semi-essential, sometimes comes under essential amino, sometimes comes under non-essential amino acid. So these are these amino acid you have to remember when you are going to counter questions regarding essential or non-essential amino acid. Now we are moving to the most important part of this video. We are going to discuss about the previous year question which asked regarding amino acid and peptides and proteins in IIT JAM, GATE as well as NET examinations. So this is the first questions from IIT JAM 2020. So in this question we have 4 amino acids present in Fisher projection. So which amino acids has absolute configuration R? This is the question of the question. So to solve this question, you have to know how to determine RS configuration, CIP rule, and absolute configuration R and S configuration, and as well as priority order. So if you give the priority order, another 1, and this is 2, this is 3, and this is 4. For priority here, in case of B, we have 1, and this is 2, sulfur is there, and this is 3, and this is 4. And in this question, in option number C, this is 2, this is 3, and this is 4. So here 1, and this is 2, this is 3, and 4. So as you know, for Fisher position, if 4th position is at horizontal position, then clockwise is S, anti-clockwise movement is R configuration. So here 1, 2, 3. So clockwise, forget 4. Clockwise, this is higher, 4th is horizontal. So this is S. Here 1, 2, 3. Anti-clockwise, and 4th is at horizontal position. So this is R. Similarly, in this case, 1, 2, 3. Clockwise, 4th is horizontal. Yes. Here 1, 2, 3. Clockwise, 4th is at horizontal. This is only one, option B is the correct answer. In this way, you will solve the question. So moving to the next question. Here this question is from isoelectric point. So based on the information given below, the isoelectric point of lysine is dash. So here in different format isoelectric point question has given. So we have a pK value 2.2, pK value 3.1, pK value 10. So lysine is a basic amino acid having net positive charge. So as this is a basic, so it has 3 larger pK value. So as you know, for positive charge amino acid or basic amino acid, if you calculate the isoelectric point, so you have to sum of 2 larger value 9.1 plus 10.5 divided by 2. Already 2 is there. So that will be the answer. So 9.1 plus 10.5, 19.6. So 19.6, that will be 9 point something. Okay, 9.8 or something. Isoelectric point will be 9.8. So in this way, you will solve the question on isoelectric point. So moving to the next question. The most basic amino acid among the following is which amino acid more basic in nature? As is tyrosine, methionine, arginine group. As you know, tyrosine group contain CH2, benzene, OH, phenolic group. Methionine contains CH2, then SCH3, okay, sulfur methyl group. Arginine contain both a guanide group NHC, NH, NH2. Glutamine, only one amide group is there. So as in case of arginine, more nitrogen groups, amine groups are there. That's why arginine is basic in nature. So for your reference, I have a answer for you. The correct option is D, arginine. So these are the structure of arginine, tyrosine, methionine. If we look at the structure of arginine, listen, this group, this one is nothing but guanidine moiety. So having more nitrogen group, as in due to the presence of lone pair present in nitrogen, so it is more basic in nature. So this question will be asked to you. So in this way you will solve the question. So moving to the next question. So this is just a synthetic or general organic chemistry type of question. So here this reactant, this is a beta bromo carboxylic acid treated with sodium azide followed by hydrogenation by palladium cut. Listen, azide is a very good nucleophile. So azide will attack to bromine. So we'll have a azide substituted carboxylic acid, and that can be reduced to form NH2 group. Azide will reduce to NH2. So we'll get a answer A, that is a beta amino acid. So to justify my answer, I have a reference for you. Listen, here azide is an excellent nucleophile. Primary amine can be made through SN2 type of azide salt with alkyl halide followed by reduction with lithium aluminum halide or palladium catalyst hydrogenation to give a amine. So this is one of the method of preparation of amine as well. So moving to the next slide. Listen, here a titration curve is given. The titration curve of alanine. So this is pH coordinate axis and this is equivalent hydroxide axis. So question at the position in the graph that correspond to isoelectric point of alanine is. Listen, if you look at this graph, this is a S graph. So here at the position of Q, this is trending. So in this position, This is at some pH, OH or pH. This is constant. So this Q or this Q, we can tell this is a isoelectric point of alanine. So if you answer this question, B is the correct answer. So Q point is nothing but isoelectric point of alanine. So this is the question, is very popular question and very easy question. Which of the following amino acid is achiral in nature? So answer is no doubt glycine. Why glycine? If you know the structure of amino acid, one carbon is surrounded by 3 constant group NH2 and here hydrogen is there. Only this position is free. If this position is substituted by hydrogen, then both two are hydrogen. This will be chiral, and this is in case of glycine. But other than glycine, all other 21 amino acid, this hydrogen is replaced by any other different group. So as this carbon is surrounded by 4 different groups, this carbon is nothing but a chiral carbon or stereogenic center or stereogenic center. So this is a asymmetric carbon. Okay, that's why all the amino acids are chiral in nature other than except glycine. So glycine is achiral in nature among all amino acids. So moving to the next question. Next question is from GATE 2012. From a carboxymethyl cellulose column, a column is there where pH is maintained at 6. Arginine, valine, glutamic acid will eluted in the order. So in the column, mixture of arginine, valine and glutamic acid is there. The elute in that will release from the column in which order? Listen, pH is 6, pH 6. So we have arginine. So arginine is a basic amino acid. So we have a pi is more in case of glutamic acid, pi of arginine, pi of greater than pi of valine, and less pi will be or pH will be glutamine in case of glutamic acid. So as pH or pi of arginine is more, that will release from the column in late. So first, as pi of glutamic is less, so glutamic acid will elute first, then valine, then arginine. Glutamic acid, valine, then arginine. So answer D is the correct answer. That is on the basis of isoelectric point. So arginine is a basic amino acid. Its pi value is more. Valine is a neutral amino acid. So valine is in between. Glutamic acid is a acidic amino acid. So pi is less than other neutral amino acid. So in this way, this will elute the system. So less pH will elute fast. So moving to the next question, the decreasing order of isoelectric point of following alpha amino acid. It was very simple. Listen, alanine is a neutral, glutamic acid is acidic, and lysine is a basic. So pi is nothing but pi is pKa plus pKb. So pKa is larger in case of lysine, pK in case of larger pK, sum of larger pK in case of basic amino acid. So pi will be more in case of lysine. Then a pi for glutamic acid, smaller pK by 2. This is smaller pK and this is a larger pK. Last question already we have discussed. Now larger pK by 2, smaller pK value. Obviously lysine will be the greater, lysine 1 will be greater and 3 will be less. So 1, 3. So answer first one is the correct answer. Okay. So in this way you will solve the question. So moving to the next question. So we have a compound like this from GATE 2013. The major product X, Y formed in the following reaction sequence are. So we have a amino acid. This amino acid nothing but tyrosine is treated with methanol and H2SO4 X with. So acidic group in case of alcohol form ester. So this one is acid in presence of methanol will form ester. Which one? Here ester. But here ester will give. But here this one will not form. Only this is the correct. Next CbZcl. CbZcl protection of amine group. benzoyloxy-carbonyl group and benzoyl carbonyl chloroformate will be used for this protection. This protection group used for protection of NH2 group. So this NH will protect CbZ. Okay. So this is the correct answer. B is the correct answer. Okay. So moving to the next question. Component of S-adenosyl methionine are A, B, C, D. Choose the correct answer from the options given way. A and C only, A and D only, B and C only, B. What is the S-adenosyl methionine? First of all, methionine. Methionine structure is SME, CH2SME. So option number. So B should be there. A should be there. That means these two are cancelled out, eliminated out. Then CD. So adenosyl means adenine will be there. So adenine obviously C. This is the adenine. So A and C. So option number A is the correct. So A adenosine methionine is a medicine. That is S-adenosyl say SAME or same. So this is the structure of S-adenosyl methionine. So here both methionine and adenine is there. Adenine reacts with a pentose sugar to form adenosine nucleoside. So this is nothing but S-adenosyl methionine. So moving to the next question. So this question asked in NET 2016 June. At pH 10, tryptophan exists as. pH 10 means high pH. So in high pH, tryptophan pH OH minus. So tryptophan present in. Oh, not this is deuterium, not the answer. So high pH. So this one high, this is not labile hydrogen. So I think this is the answer. Okay, at high pH, amino acid present in anionic form. Okay, that is the answer. Here is not the low pH. Here this should be the minus. Here this is not the more larger basic in nature. So Most appropriate answer is A. So in this way, you will solve the question. So moving to the next question. So here the major product fall in the following reaction. So this is this question comes from protection of and deprotection of amino acid. So amino acid, the NS can be protect by CBZ group or BOC group. BOC is a CBZ is benzoyl oxycarbonate, BOC is a tertiary beta-oxycarbonate. So here both amino acid is protected by CBZ group. Here amine group is protected by BOC anhydride or BOC group. Here also benzyl group is protected. So now deprotect hydrogen and palladium carbon can protect only CBZ group, not BOC. Okay, BOC is deprotected. Deprotection in case of TFA, trifluoroacetic acid. Okay, TFA. But here CBZ will deprotect. Other protection group will remain intact. So the answer will be when CBZ. This is not the answer. BOC is there. BOC. So fourth is the answer. Fourth is the answer. Okay. Fourth is the right answer. So these are the common ideas regarding to justify answer. Listen, this is NS group. This NST group can be protected by this functional group. This X can be fluorone. CO benzoyl oxide. This R, if this R will be tertiary butyl group, then this is BOC protection, tertiary beta-oxycarbonate or BOC anhydride is taken, and that can be deprotect by TFA, trifluoroacetic acid. Okay, if this R is a benzyl group, here benzyl group, this is nothing but CBZ protection. Okay, benzoyl oxycarbonate. So that can be deprotected by the palladium carbon hydrogenation, and this can be deprotected by acid. So another FMOC is another protecting group also used for NS protection. Okay, so this is the piperidine is the base which is used for this difference. So generally this BOC and CBZ protection is used for in case of amine. Okay, so here BOC can be deprotected by TFA, trifluoroacetic acid. CBZ can be deprotected by palladium carbon hydrogenation reaction. So this is the some examples for BOC deprotection. Here BOC and both CBZ and BOC is there. In case of TFA, only selectively BOC will deprotect. But in this case, CBZ will remove in case of palladium and hydrogen. Okay. So this is the some structure of different protection carbamate in case of. So amine will form a carbonate if we use the protection group. So this is the tertiary beta-oxycarbonyl BOC protection. Carboxybenzyl carboxy or carboxybenzyl is this benzyl group. So this is CBZ, total CBZ group, this one. So this is BOC group. Okay, benzoyl oxycarbonyl CBZ carbon. So this CBZ, this is the amino acid. This amino acid in presence of BOC anhydride will get a BOC protection, NS BOC protection here. If you will apply benzyl chloroformate, CBZ chloride, benzyl chloroformate, so we protect the NS group by CBZ group. So CBZ is removed in presence of palladium hydrogen. BOC is removed in presence of TFA, trifluoroacetic acid. So this is the structure of Boc anhydride, tertiary butyl, tertiary butoxycarbonate. So this is the total Boc group. So this can be protected by Boc anhydride. So this NH will protect by Boc group. And will carbon dioxide and tertiary alcohol will reduce. Saying this NS can be protected by benzyl group. This is the structure of chloroform, benzyl chloroformate. Okay, so this group is CBZ group. So we get this is NH protected. So NH CBZ. So this is all about the protection of amino acid by Boc protection and by CBZ protection. How this protection group will be deprotect using palladium hydrogenation reaction and using PFA as a catalyst. So next question, the pK value of following salt of aspartic acid are indicated below. So all the pK value is given for aspartic acid. Okay, the predominant species that would be exist at pH 5. Okay, at pH 5 mean low pH. So here the isoelectric point, larger value, a smaller value, 5.9 by 2 will be isoelectric point. So that will be 3 point something. So pH 5 means, so pH 5 that is greater than Pi value. That means at high pH. So pH 5 will be high for this aspartic acid. So at pH 5, at high pH, the amino acid remain in cationic form. That means OS minus, O minus, CO minus, that will be in deutera, this will be minus, this will be minus. Okay, this will be in deuter ionic form. This has no effect. Only this will be in minus form. So here 2 minus, but this is not plus. So this will be cutting, and this will be first ionite. This will be cutting, and here deuter ion. This will cutting. So B will be the answer. Listen, how I'll explain. So first you have to calculate the isoelectric point. So isoelectric point is the intermediate, okay, low pH, and isoelectric the high pH. So isoelectric point 5.9 by 2 will be approximately 3. So more than 3 is a high pH. At high pH, amino acid remain in anionic form, okay, means other than deuter ion. So this deuter ion is fixed. So after deuter ion formation, above the pH, that will remain in cationic form. Okay, so this will be in anionic form. So B is the correct answer. Okay, next, moving to the next question. The amino acid constituent of artificial sweetener aspartame, artificial sweetener given following. So this is nothing but a peptide chain. Amino acid combined to form a peptide. So what are these? So this is the structure of CONS, CH2CH, is glutamic acid is there. Here another amino acid, this is phenylalanine, glutamic acid, phenylalanine, glutamic acid, phenylalanine. Here this 3 is cutting, glutamic acid is there, aspartic acid is there. So aspartic acid, this one is cutting, aspartic acid, and phenylalanine. So this is the 3 number is the, so this is CS2COH is aspartic acid. So aspartic acid should be there, L-aspartic acid, phenylalanine. In case a tyrosine is not there, so 3 is the correct. Only you have to judge the structure. If you know the structure, that's why I repeatedly telling you that structure is very, very important in this chapter. So you have to remember the structure of each amino acid, so that you can answer this type of questions. Okay, moving to the next question. The heterocycle ring present in amino acid histidine. In histidine, which amino acid, which heterocycle is present? So simple, histidine contains imidazole ring. Okay, indole contain which one? Tryptophan indole contain. Tetrapyrrole pyridine is not there, indole and imidazole is present in the amino acid. So this is very, very easy. Moving to the next question. So this is a question from NET. Major product B form in the following reaction sequence and overall yield out its formation of each. So listen, we have given the S-glutamic acid. Okay, glutamic acid treated with aniline. Then A followed by lithium aluminum hydride reduction to form this. First, what happened when S-glutamic acid is treated with aniline? So, yes, to explain this question, we have to move the next slide. So, this is nothing but S-glutamic acid. When S-glutamic acid treated with aniline, so this COH comes contact with this amine group, okay, and form this amide here. In the next step, this nitrogen will attack this carbonyl group, or this hydrogen and this OH will combine to form another amino acid. So listen, this NH2 will attack to this one to form this cyclic type of structure. Then this cyclic in presence of lithium aluminum, you know the lithium aluminum hydroxide is a reducing reagent, reduced amide group, amide carbonyl to CS2 group, CS2 here also. So lithium role of RCONS2. So lithium aluminum hydride LH reduce this CO to CS2 group. This is coming under general chemistry. So CO will convert to, here is cyclic amino acid is there, amide is there, CO, and this CO will convert to CS2. So in this case, we have started from S amino acid, S glutamic acid, and we will get here no stereochemistry is not changed, so we will get the S product. So in this case, listen, we have S glutamic acid, we will get the S amino acid. So answer A or B. Listen, how will know this is a S? So from this stereochemistry, absolute configuration will be, so absolute configuration, hydrogen is niche, so this will be 1, and this is 2, and this is 3. So 1, 2, 3, 1, 2, 3, anti-clock, 1, 2, 3 anti-clockwise. So this is S, and this is also S. So now 48%, this is the yield. Listen, here this is general IQ. So first, in case of aniline, when glutamic acid react with aniline, 60% reaction, then 80% reaction. Obviously that will not 70%, that will remain at 48%. So you can calculate by formula, but in generally we will get 48% overall yield here. Okay, by using this knowledge, you can analyze the answer. So answer A is the correct answer here. Okay. So this is the explanation already we have discussed. So moving to the next question. Toxicity of cadmium and mercury in the body is being reversed by protein. Toxicity of cadmium and mercury in the body is being reversed by protein, mainly using which amino acid? Listen, very interesting question. Listen, if you look glycine, leucine, lysine, cysteine. In all the case, glycine, NH2COS is there, leucine, 4CST group is there, leucine, isopropyl group CS2 is there, in lysine, NH2 is there. But in case of cysteine, SS group there. Listen, SS is a soft soft base. Okay, so you know, according to hard soft acid base concept, hard acid prefer to hard base, soft acid prefer to soft base. As you know, cadmium and mercury are soft acids, so that will combine or coordinated with amino acid having soft bases. So sulfur is considered as soft bases. So that's why in this question the correct answer cadmium mercury can be reversed back by the protein by using cysteine amino acid. So cysteine is the right answer. Okay, so to explain this one, cysteine contains sulfur, cadmium mercury has high philic to sulfur. So cysteine binds to mercury and cadmium, hence their toxicity decreases. That is, soft acid prefer soft base. So this is the explanation for this answer. So moving to the next question. Among the following, the amino acid which is a basic in nature. It's very already we have discussed this question again asked in NET 2012. So answer Arginine is the most basic in nature due to presence of guanidine moiety. So next, so this is the question from NET. In metalloenzyme, enzymes which contain metal, the metal centers are covalently linked through the side chain of amino acid residues. The correct set of amino acids which are involved in the primary coordinate. So there is a metal enzyme, metals are surrounded by enzyme. So enzymes are nothing but proteins. Proteins are consist of amino acid. Which amino acid will help to coordinate the metals? Listen, that amino acid will coordinate the metal which have a ligand character, which have the coordination, having coordination capacity or can behave as a ligand. Listen, in case of this alaline, do a different step there. Alaline is a polar. Okay, alaline is a polar. CS2 pH there, it cannot coordinate benzene ring there. In case of leucine is a isopropyl group is there. Okay, that can coordinate. Histidine can coordinate. So histidine can coordinate. Then glutamic acid, yes, glutamic CO minus is there, extra CO minus. So that can coordinate glutamine. Cysteine having SH group. Okay, this sulfur can coordinate, no doubt. Cysteine. Okay, here leucine cannot. Glutamic S, cysteine S, histidine, glutamic. Here alaline, histidine is glutamic. So which one is the complete answer? B is the complete answer. So in this way you have to solve your question. Okay, so this is the actual answer of this question. This combination of these three amino acids can coordinate the metal in metalloenzymes. So now this is another magic question from NET. Match the amino acid with their structure. Very, very easy. Listen, so this is nothing but a structure of glycine. Sorry, structure of CH, here NH2CO, CH2CO1, glutamine, okay, CH2 asparagine. So this is the structure of asparagine. And this is a which group? Indole is present, indole present in tryptophan. So this the then this is a histidine, okay, histidine part. Imidazole ring is there, histidine where histidine. So this combination is a right combination. IC, where is IC, both IC, then IC, then double IA, and triple IB. Okay, so this is the correct answer. In this way, you will solve the question. Very, very easy. You have to remember all the structures so that you can answer this type of question very. Now coming to the next question. So this part of question is coming from peptides. So as you know, amino acid combine with each other to form peptides by forming peptide bond. So peptide bond, amino acid combine with each other to form a peptide chain. So peptide chain has two terminals, N terminal and C terminal. So N terminal can be analyzed by N group analysis. C terminal can be analyzed by C terminal. That means by N group analysis, we can know the sequence of amino acids present in peptides. So to solve this question, we should have some basic idea about N group analysis. So before solving this question, we should go to some basic of N group analysis. Listen, the N terminal of amino acids, these are the amino acids combined with each other. So this is arginine combines with each other by using peptide bonds. So this is a proline, and this is coming with another proline, glycine, phenylalanine, serine, phenylalanine. So this is the amino acid chain combine with each other to form a peptide bond. So listen, this is N terminal and obviously this is C terminal. So ends with amine, that's why this is the N terminal, and this is C terminal. Suppose we have a unknown peptide having different sequence of amino acid. So by using amino acid analyzer, we can know how many amino acids are present, what are these amino acids. But we can't tell by using amino acid analyzer which amino acids are arranged in which sequence. First is arginine, suppose next is proline, next is glycine. This sequence we can't detect from the amino acid analyzer. So for that, to know the sequence of amino acid, we will apply two analysis, that is N group analysis, N terminal analysis and C terminal. So N terminal analysis done by two chemical method, one Eadman degradation, another by using Sanger's reagent, and C terminal can be analyzed only by using carboxypeptidase enzyme. Okay, so N group analysis, Eadman degradation, what is the Eadman reagent? In Eadman degradation, this is the three steps of analysis of N terminal by using Eadman degradation. Listen, here in Eadman degradation, which reagent is given? Phenyl isothiocyanate. Phenyl thiocyanate, isothiocyanate is given. At the N terminal, this NH group attached to the carbon nucleophilic attack by the free amino group on phenyl isothiocyanate, followed by protein transfer to this type of product. So then this will rearrange to form this phenyl thiourea. The next step, by treatment with HCl, induces a cyclization to thiazolonine explosion. So this cyclic will form. So eventually this cyclic compound will form, and this part will eliminate from them. So this part is nothing but a residue of terminal amino acid. Listen, this green part comes from, this green part is the part of which reagent, phenyl isothiocyanate, and this black part is nothing but part of N-terminal amino acid. Listen, if you will detect this compound will isolate from this compound, we can know by analyzing this R1 group, this is the part of which amino acid. So from the N-terminal, this is N to C terminal, one N-terminal, from the N-terminal, one amino acid will eliminate from the chain. So this will detect, suppose this is glycine, then another N-terminal will, one amino acid will detect, that may be alanine. So likewise from N-terminal to C-terminal we can give different sequence. So these things you have to study from your text. Just I am giving you a brief idea about N group analysis by Edelman degradation. So here phenyl isothiocyanate. So first amino acid will react at N terminal, will react by phenyl thiocyanate. So first amino acid, suppose alanine, from N terminal, then next will be glycine, that will be detected by this phenyl thiohydantoin complex. Okay. So similarly, by using Sanger's reagent, Sanger's reagent is nothing but 2,4-dinitrofluorobenzene. Okay, this is 2,4-dinitrofluorobenzene, that is Sanger's. Similarly, at the N terminal, this reagent reacts with the NH2 group at N terminal to form this type of derivative. Okay, this type fluorine hydrogen will combine to form HF, will get this derivative, and further in presence of acid that will hydrolyze, this part will hydrolyze, and this part comes from which amino acid, N terminal amino acid. So then again this 2,4-DNF B will act upon another N terminal. So similarly we will get a 1,1 amino acid from N terminal to C terminal. So similarly, by using carboxypeptidase enzyme is used for C terminal analysis. The role of carboxypeptidase enzyme is nothing but cutting from the C terminal. It will cut from this side. Okay, so we'll get from C terminal, C to N terminal. From C terminal it will cut one by one. That's why carboxypeptidase is called as biological scissor. Okay, for cutting of peptide bonds. Okay, so by using this concept we can answer this question asked in GATE. A tripeptide on treatment with phenyl isothiocyanate pH 8 followed by heating with dilute HCl afford a cyclic compound N. So N is the first compound. Okay, then a dipeptide tripeptide, dipeptide on treatment with phenyl isothiazine, again hitting with diluted cyclic compound N, then cyclic compound O. Listen, this is the first compound from N terminal, correct sequence from N to C terminal. Okay, very easy. So this is the first compound will form by using Edman degradation. So this compound, this part is from, okay, this part comes phenyl thiocyanate, isothiocyanate, and this is the part from amino acid. So this part from amino acid, hydrogen is there. So that's why this amino acid is nothing but glycine. So this complex formed by using glycine from N side. So glycine should be there. Glycine here, glycine here, glycine here. Then we'll get N from glycine. Then we'll get a N product. So this is the compound from which part? This part. So this is nothing but phenylalanine. So glycine, then phenylalanine. Okay, phenylalanine, right? Then we are getting O. This is the last product. This is nothing but valine. So here is the valine. So answer is A. Okay, A is the correct answer here. So this question can be solved by using this peptide N terminal analysis by Edman degradation. So if you study the Edman degradation, so you can solve this question very easy. So this is the Edman degradation product. So in this way you will answer this question. So coming to the next question. So next question is a tetrapeptide made up of natural amino acid has alanine N-terminal residue which is coupled to a chiral amino acid. Upon complete hydrolysis, tetrapeptide gives glycine, alanine, phenylalanine and leucine. Number of possible sequence. It is made of natural amino acid. So natural amino acid has alanine end. Suppose alanine at N terminal. Okay. So alanine should be at the end terminal. Tetrapeptide contains glycine, alanine, phenylalanine. Okay, alanine is in then glycine, then phenylalanine, then leucine. Okay, then is given. So alanine has N-terminal ratio which is coupled to a chiral amino acid. Okay, chiral amino acid, glycine is not a chiral amino acid. That means alanine can join with phenyl, can join with leucine, cannot join with glycine. So if you give the combination, then alanine will start first. Alanine, leucine, phenyl, then glycine. Again will change alanine, leucine, glycine and phenylalanine. Then again alanine will join with phenylalanine, leucine and glycine. Again alanine, phenyl will be intact, only will swap glycine, leucine. Okay, so these are the four sequences are possible for a tetrapeptide. Here you can see glycine is not attached to alanine because that is given one condition. N-terminal ratio alanine can join to a chiral amino acid. So this is chiral, okay, and this is phenylalanine chiral. Suppose, and these are the four possible. So we'll get four tetrapeptide, four number of possible sequence are possible. If that will attach with alanine with glycine, alanine glycine, another two is possible, but here glycine is not chiral. This is a chiral. So got it my question answer. So we get The question asks that alanine should be at the end, okay, but condition is there. The tetrapeptide, other amino acid will join with it next to alanine. That should be chiral. So leucine is chiral and phenyl is chiral. So when leucine is combined, phenylalanine will attach, glycine attach. Though this phenyl glycine will swap, another sequence will get. Again alanine will be phenylalanine and phenylalanine. Now leucine glycine will swap. So these are the four possible sequence tetrapeptide will get from this compound. Okay, so this is the answer of this question. Please think over it. It is a very quiz type of question. Okay, moving to the next question. Very easy. The correct sequence of amino acid present in tripeptide given below. If you look at this tripeptide structure, if you know the structure, you will identify very well. So this is the structure from valine, and this is the structure from serine, and this is from 309. Okay, 309 is there. So valine, VL, then serine, SCR, then 309, TH3O, THR. Which is the sequence? Valine, serine, 309. Valine, serine. First one is the correct answer. Okay. So this is very easy question to answer. Then this question comes from Sangar's reagent. What is Sangar's reagent? Sangar's reagent. So you know already we have studied about the Sangar's reagent. What happens with the Sangar's reagent? The N terminal, this N terminal reacts with fluorine. Then this will be hydrolyzed, and this amino acid is cutting from this fluoro part. So we'll get this NS part. This is the nitro NS. And methyl COS there. Here nitro NH. This is not coming. This is not the answer. Obviously same things will. This is not answer. Stereochemistry will not change. And this is no possibility. And this is the answer. So A is the answer. If you go to the Sangar's reagent or Sangar's reagent for N group analysis of amino acid, then you can get your answer. Already we have discussed in the last slide. If you want to go that slide, so this is the Sangar's reagent. So this is the Sangar's reagent that will react with N terminal amino acid peptide. So the amino acid present at the N terminal will segregate from the peptide chain with Sangar's reagent, and then that will be hydrolyzed further. So this question is from Sangar's reagent. So this is the answer. A is the answer. So moving to the next question. Listen, this is very important question. Cyanogen bromide, CNBr, specially hydrolyze the peptide bond formed by the CSIR. Listen, cyanogen bromide, like a carboxypeptidase, is the enzyme which got at the C terminal. Cyanogen bromide is a specific chemical which got the peptide bond at the C terminal having methionine. Wherever methionine will be there, at that side cyanogen bromide will cut the peptide bond. So answer is methionine. These things you have to remember. Cyanogen bromide is a chemical used for cutting a peptide chain at C terminal where methionine is present. Only this is very specific in nature. What is specific in nature? Okay. So moving to the next question. This is the total specific enzymes used for specific cutting. Listen, hydrolyze the peptide in smaller. Trypsin is the enzyme which cleaves at lysine arginine. Wherever lysine arginine is there, in that case trypsin will cut at that point only. Trypsin will cut the peptide chain where lysine and arginine is there. Similarly, chymotrypsin will cut the peptide chain when phenylalanine, tyrosine and tryptophan is there. Tyrosine, tryptophan, phenylalanine. Similarly, pepsin will cleave at phenylalanine, tyrosine, tryptophan, leucine, aspartic, glutamate. The broad spectrum. Cyanogen bromide, not an enzyme, is a chemical used to cleave at methionine. So these things you have to remember: trypsin at lysine, arginine; chymotrypsin, phenyl, tyrosine, tryptin; pepsin cleaves at various lysine. So these things you have to remember which specific enzyme codes at what side of peptide. Okay. So moving to the next one. So this is the question for you. Very treatment of pentapeptide. So pentapeptide, 5 amino acids are combined to form pentapeptide in a separate experiment with enzyme trypsin. So separate experiment. Suppose experiment is 7. In one experiment, that pentapeptide will give in trypsin. In another experiment, that pentapeptide will be given by chymotrypsin. In another experiment, that pentapeptide will give in carboxypeptide A respective. What will be the product? This in first case, this in trypsin is given. So trypsin only cut lysine and arginine. Listen, that will cut at arginine. Okay. So we'll get in first experiment glycine, arginine. So glycine, arginine, where cutting, then another glycine, arginine. Okay. So BJ. Then in another experiment, same pentapeptide is given by chymotrypsin. Chymotrypsin, phenylalanine, tryptophan, tyrosine. So phenylalanine, so phenyl chymotrypsin will give phenylalanine. Phenylalanine is here is the phenylalanine. So and arginine, tyrosine, tryptophan is not there. So in the next experiment we'll get glycine, arginine, and this is case 1, this is 2 experiment. So we'll get glycine, arginine, phenyl, alanine. So here it will cut. So we'll got this section here. So glycine, glycine and these things. So this is second experiment. So glycine, arginine, phenylalanine, glycine, arginine, phenyl, alanine. In the 3 cases are same. Okay. Then after cutting we are getting this fragment. Okay. In the third experiment will carboxypeptidase. Carboxypeptidase, suppose this is N terminal. Carboxypeptidase will cut at 1C terminal. We'll get alanine here. Okay. Here alanine. So we have a phenylalanine. We have a, this is not the, in the 2 position it will not, only one will cut. So this is not plus alanine, glycine, arginine, phenylalanine. So this is not answer. Glycine, arginine, phenylalanine. Okay. So that will only carboxypeptidase will cut only one at a time. One amino acid at C terminal it will cut. So alanine will cut. This alanine will cut. Then this fragment will be in the solution. This fragment will be in solution. Alanine. In chymotrypsin at phenylalanine or tyrosine tryptophan. So phenylalanine, it will cut at phenylalanine, we'll get this fragment and this fragment separated. So we'll get glycine, arginine, phenylalanine, and this part is alanine. In the first end trypsin, so trypsin will cut at the arginine side, we'll cut this one, So this fragment will separate out. We'll get glycine and arginine. So answer A is the correct answer. Analyze. Whatever I have told you, that is the specific enzyme used for cutting at a specific amino acid. If you cut that fragment, so that will separate in different fragments. If okay, so we'll get the question A. So if you not understand, you try to analyze single experiment. First one experiment, you got that fragment will take, this is one fragment, this is one fragment. When that pentapeptide used by trypsin. In the second experiment, same pentapeptide will given by chymotrypsin, so we will get one fragment and another fragment. Same pentapeptide when will be given by carboxypeptidase. Carboxypeptidase at C terminal only cut at the C terminal for one amino acid. So it will cut here. So we'll get alanine one last C terminal and the another 4 amino acid, that is tetrapeptide, will remain in. So A is the correct answer. Okay. So A is. Next question is, a peptide A on reaction with 1-fluoro-2,4-dinitrobenzene followed by exhaustive hydrolysis, that means Sanger's reagent, gave phenylalanine, alanine, serine and N2,4-dinitrophenylglycine. This is the end product analysis from Sanger's reagent. Other hand, peptide A after 2 cycles of Idman degradation give phenylserine as the product, and structure of peptide A is. So first one is N2,4-dinitrophenylglycine. So glycine will be at the end point. So glycine. Okay. Next. On the other hand, peptide A after 2 cyclic Edman degradation gives phenyl and serine as the product, byproduct. So phenylserine at the end. So glycine will be the first one, glycine. So the answer is here, N terminal. So glycine, then we'll give alanine. In the last product, we are getting phenyl and serine. So C is the right answer. From N terminal to C terminal. So in Sanger's reagent, we are getting this product with glycine. Then after hydrolysis, we will get again alanine. Then the end product phenylserine. So this is the sequence of amino acid in this tetrapeptide. So this is the again another question from Idman degradation N group analysis. So tripeptide following products in Idman. So this is the cyclic product from Idman degradation. So this part comes from phenyl isothiocyanate. Okay. So this comes from the corresponding amino acid present at N terminal. So this is nothing but phenylalanine. So phenylalanine here and here. Okay, this one is not the answer. So then we have the N terminal after phenylalanine. This is alanine. Okay, where is alanine? Alanine is there. Okay, alanine is there. Then this is glycine. Glycine is there. Okay. So this is the correct answer for this question. So this is the correct tripeptide. Answer is the correct answer. Okay. So this is all about our question regarding peptides. So in this way, only you have to remember N group analysis by Idman degradation and Sanger's reagent and some specific enzyme which are responsible for cutting the peptides at a specific amino acid side. Okay. So this is the one sequence of amino. A long chain peptide is there. So you just look at this. This is cyanogen bromide cuts at the methionine side. Trypsin cuts at lysine or arginine. Here trypsin cuts at arginine side. Here cyanogen bromide cuts at the methionine side. Similarly, trypsin at the different. This is the specific enzyme cuts at the specific site of peptides. Okay. So coming to the next question, tetrapeptides that gives the following products on reaction Sanger reagent followed by hydrolysis is are. Okay. Tetrapeptides. Suppose these are the four tetrapeptides are given. Which tetrapeptides upon Sanger's reagent? If we will use the Sanger's reagent, which tetrapeptide will give the first product? This one by using sun. So Sanger's reagent reacts with the amino acid present at the N terminal. So this amino acid, this part of this amino acid is present at the N terminal. What is this? This is the part of which amino acid? Methyl is there. Means alanine is there. So alanine is there. Alanine is there. Okay. So alanine is there. So that is the answer. Tetrapeptides means more than one answer is possible. So A and D is the answer. A and D is the answer. Okay. So maximum number of dipeptide that could be obtained by reaction of phenylalanine with leucine. Very simple. Phenylalanine NH2. Okay. CHCOH is there. Okay, suppose NH2 C phenylalanine CS2 PH is there. Okay, here H, here COH is there. Okay, this is phenylalanine. What is other is a leucine. So leucine, you know, CS2, CH, here CS3 and CS3 is there. Okay, here COH will there. Okay, here NH2. No, is that? So maximum number of dipeptide. So here COH and this NH2 can form one peptide, dipeptide. Or this NH2 can combine with COH, another dipeptide. So maximum 2 number of peptide is possible. 2. So answer is the 2. Very simple question. How many by using 2 amino acid? How many maximum amino acid can form? 2 peptides can form. Okay. So moving to the next slide. Cyclization of following dipeptide under mild basic condition. So this is asked in NET 2020. So cyclize, this will cyclize to form this. Listen, it is very interesting. There, this can react with this one, this can react with this. So I'll explain you this one. Nitrogen, oxygen. So nitrogen is more nucleophilic in nature. That's why this one, okay, this one reacts with this one. Ester group is there, so that will polarize away, and O minus will be there. OMe, you know, OMe is a good living group. It will come and this will polarize out. So we'll get a cyclic product 1. If will number 2, 3, 4, 5, 6. So 6 member will get. So 6 member, this is 6 and this is 6. So which one is the correct? 6 means 1 2 position ratio. Suppose 1 is the, this is 1, this is 1, okay, and this is 2, this is 3, 4, 5, 6. So listen, 1 2 position CS2 was there, 2 position 1, so 1 2, 1 2 3, 1 2 3 4, 1 2 3 4. So 1 2 3 4. So both are, listen, these two are same, but listen what happens here. No stereochemistry will change here, because the stereochemistry strengthener has no effect on this reaction. So we'll get 2 is the answer here, okay, 2 is the answer. So we'll get answer cyclic product. So listen here, reaction of dipeptide given below, hydrogen in present tense of palladium. So listen, here is nothing, very simple question. Please, palladium carbon is used for deprotection of CBZ group. Where is CBZ group? Listen, this is CBZ. This is nothing but CBZ protection. So CBZ protection done by palladium and carbon. So if you look at the mechanism of CBZ, we will get the, after deprotection, we will get a, which amino acid is a peptide N protected. First this one will be, this is from phenylalanine and this is from leucine, phenylalanine and leucine. So phenyl glycine is not there, phenylalanine and leucine is there, okay. So what is the, after deprotection we will get carbon dioxide as byproduct, and this will periodical here toluene, benzene CS2 dot or minus will be there, toluene will get carbon dioxide, okay, carbon dioxide, but here toluene will be there, okay. So the 2 is the right answer. So deprotection of benzene CBZ group, where it is protected by a protected NS group. So deprotection gives rise to carbon dioxide, toluene and free NS2 group. So we'll get this. And so answer question number 2 is the right answer. So this is the constituent of amino acid present in the following dipeptide. What is the dipeptide present? Listen. So this is nothing but CS2COH. CS2COH means this is a aspartic acid, okay, aspartic acid, and this is 4CS2, this is lysine. So aspartic and lysine, aspartic, lysine. So these two, then RS configuration. So here RS, this is hydrogen, here is a dioxide, hydrogen is there, hydrogen, okay, this is 1, this is 2 and this is 3, 1 2 3, anticlockwise, hydrogen is below the ring, below the plane, anticlockwise, S lysine, where is S lysine? So S lysine is here. The answer A is the, no need to do the organic aspartic acid. So in this way you can answer your question. So this is the very simple way. First of all, you have to remember all the structure of amino acid and some basic things about dipeptide, so that you can answer the questions very easily. So thank you very much all the viewers. So keep on watching Ag Chemistry by Ashish sir, and if you like this video, please subscribe my channel Ag Chemistry and comments, like and comment and subscribe my channel. I can see. Thank you very much, my dear viewers. Thank you.